So now we are going to learn about generating data. So first of all, the very first kind of generation model that we are going to see is Gaussian. So 1D Gaussian we are now going to generate. Okay, so using this command, what we are going to do is we'll have a vector inside X which has value from -4 to 4. There would be 100 values within -4 to 4 range. Okay, and then what we will do using the function denorm, we will pass the value X as one of the argument of denorm, and the mean and standard deviation of the Gaussian that we want. Okay, so this is the general formula of 1D Gaussian. So what will happen, or what this function will do, one by one, the each and every value that is inside at X vector will be substituted over here. The mu value that or the mean value we have specified over here. Standard deviation is this value. So basically all parameters that we have specified, and using this formula we will get each y with respect to each number in X array. So we will get 100 length of the vector having 100 length of y. Now this will be our Gaussian vector. So if we will plot a graph, so it should look something like this. When we are plotting graph, something like this. Let's see if it's there or not. So this is the plot function. Using this function, you can see your output and determine that whether it is Gaussian or not. So let's run it. So here you can see this is the plot that we got. Now it certainly has the value from -4 to 4. We have specified it at the time of declaring X, and these are various Y values that we got from this formula: mean equal to 0 and standard deviation 8. Okay, so if you want to play around, then if we are using a less standard variation, let's say standard deviation. So now, so this is the curve, new one. So if you have noticed, so there is certainly change in the spread of this curve than the previous curve we have seen. It's just because of the standard deviation is changed. So the next model that we are now going to see is the exponential model. So this is the command using which we are now going to generate 100 length of vector which has the value between 0 to 2. Okay, so using which you will generate the vector X. Now using this command, what we are doing is supplying the value X into the formula. So now this is basically in the formula of exponential distribution, and this over here is the quantity we call rate. So as you can see, we have specified rate equal to 4, so the value of lambda is 4, and the value of X will be will get from this vector. Okay, so using this function, now we are going to get certain distribution, and if we plot the distribution, okay, so I have already plotted that. So this is the distribution. So that's basically the curve that's going to generate. The next distribution that we are going to see is uniform distribution. So this is the formula or the command dunif, using which we can generate the uniform distribution given X vector. So we will now generate and let's plot it. So it's just because the vector is from let's say minus to plus range. The graph plotted here is in two parts, but let's see if we are taking a positive value. Okay, then okay. So now we have taken vector from 2 to 100, and the uniform distribution that we are going to make has minimum value 2 and maximum 100. So when we are making the plot is something like that. So you can see this plot is starting something, the slightly behind zero. And there are actually so many values, so we can't accurately see that. But you can see that it's starting from 2 till 0, and the height it's receiving is according to this formula. So this is the minimum or maximum number, and the minimum number is we have specified was 2, the maximum was 100, so it should be like now the height was 100 minus 2, it's now, so it's nearly equal to 1 by 100. So you can see that. So the height is 0.010. Okay. So till now we have seen how to generate certain distribution when we are passing x vector as an argument. But now we'll see that if we do not pass any kind of x vector, and in fact we want certain x vector which belongs to certain kind of distribution, so that we can achieve by using this command. So assume that now let's see, you have something this kind of scenario. So this is why we are to show this thing, I'm limiting myself to 2 dimension. Otherwise this thing can go till n dimension itself. But this is the x. Now I want a distribution for which if I'm using the same parameter value, the y should be like this. So it's a normal distribution. So instead of dnorm function, I will use rnorm, and instead of passing x, I will specify how many number of x I want, and the parameter that I passed in dnorm will be same. So according to this parameter, I want this set of value. So in dnorm, I was passing this set of value, and in rnorm, I am getting this set of value as answer. Okay, and that you can specify for each and every distribution that we have seen. For uniform, we have seen dunif. For exponential, we have seen dexp. So at each and every models or curves name, instead of d, if you replace d with r and then use that generating curves name, yes, you can generate the same way as we are going to generate this distribution, the normal distribution. So now we are generating 1000 numbers which follows random or normal distribution with mean equal to 0 and standard deviation equal to 8. So I am going to store all those numbers into x vector. Now if I want to realize that it is the number that I have generated are in a normal form, then now I cannot use the plot function, because what does plot gives me an answer. It basically takes an y coordinate, x coordinate, and then it will give you answer. So where they belong. But now I have x distribution. So to know that it is really a normal or not, what I need is, for example, this is the value of x, and how many instances of this value are present in my data set. So let's say there are 4 instances. So there will be a bar over here, and for this value, let's say there are certain 5 instances. So something like that. Uh, so this sort of diagram will give me that information that, okay, now my distribution is, it looks like that it is normal. Okay. So let's see. So that we can use hist keyword. Okay. So hist basically gives you the histogram of x. At x-axis, you will find the value of x, and at y-axis, you will find the frequency or the number of occurrences of x. So here we can see it looks fairly like it's Gaussian. So now we have tried the same thing with n equal to 20,000, mean 0 and standard deviation 8. So you can see that the middle element is at 0, and it's giving the feeling of standard deviation of 8.